This video provides an introduction to rational functions. A function f of x is a rational function if f of x equals n of x over d of x, where n of x and d of x are both polynomials and d of x is not equal to 0. So basically, a rational function is a function that has a variable in the denominator. The domain of f of x is a set of all real numbers x such that d of x is not equal to 0. As we know, we cannot have a 0 in the denominator of a fraction. So to find the domain of a rational function, we set the denominator equal to 0, solve, and exclude that value from our domain. Let's state the domain of f of x equals x minus 2 over x squared minus 3x minus 4 in interval notation. We start by setting the denominator equal to 0. We're going to solve this equation to find the values of x that must be excluded from the domain. This quadratic factors nicely. X minus 4 and x plus 1. Setting each of these factors equal to 0, we'll solve and find the values to exclude. X equals 4 and x equals negative 1 must be excluded from the domain of this function. To get the correct interval notation, I always like a number line. We don't want negative 1 and we don't want 4, but we want everything else. To the left of negative 1, in between negative 1 and 4, and to the right of positive 4. Our domain will be negative infinity to negative 1, not including. Then from negative 1 to 4, and 4 to infinity. If a function is not defined at a point, then it's still useful to know how the function behaves near that point. So let's consider the graph of f of x equals 1 over x. Since we cannot have a variable in the denominator of our fraction, we know that x equals 0 is not a point in the domain of the function, because when x is 0, we get an undefined expression. We should, however, ask the question, how does f of x behave as x approaches 0? Well, x approaches 0 either from the left side or from the right side. We're going to look at these two sides independently. We'll start with as x approaches, this little arrow here means approaches, 0 from the negative side, which would be the left. So as x approaches 0 from the left, we want to talk about how f of x, or the y value, behaves. So here's our graph, and here's where x is approaching 0 from the left. What's happening to the y value of our function? Notice that our y value is pointing down. It's getting smaller and smaller and smaller. The y value is approaching negative infinity. Since x cannot be equal to 0, this graph is never going to cross the y-axis. It's not making a turn like this. It's going to get closer and closer to the y-axis, but never touch it, never cross it. Now let's look at what's happening as x approaches 0 from the other side. As x approaches 0 from the right, let's talk about what f of x is doing. So here we are, x approaching 0 from the right. Notice that the y value is getting larger and larger and larger. The y value is approaching positive infinity. Again, the graph is never going to cross the y-axis. X equals 0 is not in the domain. Also think about it. On the right side of 0, it's all positive numbers. If I'm plugging a positive number into f of x equals 1 over x, that means that I'm going to have positive 1 over another positive 1 over another positive number. A positive over a positive always leaves us with a positive. So it's never going to cross over to the left side of the y-axis. Let's also look at what's happening to the graph this time as x approaches negative infinity. Let's talk about what's happening to the y value. As x approaches negative infinity, here we are. Notice that it looks like our graph is like leveling out. Our graph is getting closer and closer to the x-axis, but it's never going to cross the x-axis. All the numbers, the x values to the left of the y-axis are negative x values. If I plug a negative x value into my function f of x equals 1 over x, I'm going to have positive 1 over a negative number. That's always going to give us a negative number. So our y value is always going to be negative when our x value is negative. Therefore, we'll never cross the x-axis and move into positive y values. We're getting closer and closer and closer to 0 from the negative side. Similarly, let's look as x approaches positive infinity. What's happening to our y value? As x approaches positive infinity, again, it looks as if our graph is leveling out. Notice that our graph is getting closer and closer to the x-axis. Just like with the other side, our graph is never going to cross the x-axis. This time, as x approaches positive infinity, f of x approaches 0 from the positive side. This graph had two different lines that it was getting really, really, really close to, but never actually touching or crossing. It happened on the x-axis and on the y-axis. Asymptotes are lines that a function approaches but does not actually touch. We're going to be discussing three types of asymptotes: vertical asymptotes, horizontal asymptotes, and oblique asymptotes. Be sure to watch the 3 videos on the asymptote types.